Now we move to Diego Martín Carrero that will present to us the CESAR remote telescopes for educational purposes. I'll give you the floor, and in 15 minutes more or less, when you have three minutes left, I will let you know, okay? So the floor is yours. You can share your screen.
Can you see the screen?
Yes, we can.
Yeah. So, hello everyone. My name is Diego Martin. I'm a Master in Astrophysics student, and currently I'm doing an internship in the European Space Agency, working for the CESAR team. My main task is the implementation of the CESAR observatories. This is what I'm going to be talking about. So, first of all, you probably all know what is the. Okay, so before we begin, I would like to briefly introduce the CESAR project. Probably most of you already know what this is about, so I will try to be as fast as I can. So CESAR stands for Cooperation through Education in Science and Astronomy Research. It's a science outreach initiative led by the European Space Agency in collaboration with INTA, the Spanish National Institute for Aerospace Engineering, and ISDEFE, a public enterprise focused on defense and space issues. So the main objectives of the CESAR project are to foster interest in space science and technology using real data to make learning more meaningful. And we also aim to encourage scientific vocations, critical thinking, and scientific culture. So in this slide, you can see what are we doing in order to achieve the objectives that I said in the previous slide. So my workmates, Carmen Jaukes and Carmen Ayepur, have already talked about several of them, such as the space science experiences, the teacher training courses, the commitment of CESAR for inclusive and diversity things. So I will focus my talk on the last point of the slide, which is the use of telescopes for educational purposes. First, I would like to show you an overview of the CESAR observatories. We have observatories in two different locations. Here in ISAC, the European Space Astronomy Center, in Villanueva de la Cañada in Madrid. Here we have three observatories: the Helios Observatory, which is used to observe the sun, the VIL1 and VIL2 antenna, which are located here. And with this one, with the VIL1 antenna, we used to send the telegrama on Planeta, which Beatriz was talking before. And also the Nix Observatory, which are two equal night sky telescopes. We also have an observatory in ISA Deep Space Station, located in Cebreros, like 100 kilometers away from ISAC, which will be hosting the CCT, the Cebreros CESAR telescope. And currently, just the Helios telescope is fully deployed. The rest of them are still being prepared. So let me talk about this observatory first, and then we will talk about how are doing the rest. So this is the Helios Observatory. It is located in ISAC, as I said before. It is formed by three telescopes: one 11 centimeters Coronado telescope and two 9 centimeters Bresser telescopes. Each of them is equipped with a CCD, a dedicated CCD, and they are mounted in a Skywatcher EQ8R mount. So we use three telescopes so we can see different structures in the sun photosphere. Each of them is equipped with a different filter, so we can see different features of the sun. One of them is equipped with a white light filter, another one with an H-alpha filter, and the last one with a calcium K line filter. Everything is protected by a dome, a scope dome, and we use a master computer to control everything. So just a simple scheme of how everything is connected and how everything is working. Each of the CCDs are connected via USB to the master computer, and so is the mount. Then to control the dome, we use a control board, which has multiple uses. It is in charge of controlling the azimuth rotation of the dome. We also use it to communicate with the master computer, and finally to communicate via radio with the control board, this one over here, which controls the opening and closing of the sub. All of the system relative to the dome has been designed by Astropolar. So with everything connected to the computer, we use ASCOM to communicate with all the hardware, and a Python-based app that we have designed, which is called Hyperion. this is used to take the images and to control everything, the dome, the telescopes, and all the cameras. This is an overview of the Hyperion app. We have tried to do it as simple as possible, as we are going to use it for live observation of the sun with the schools. So in CESAR, we have schools coming to ISAC weekly to do one of the activities that we offer, the space science experiences that Carmen talked about yesterday. And this course, we are going to add a new feature to our solar activities. The idea is that they take themselves the image that they are going to use in the next steps of the activity. For that purpose, we have designed this app, which is very, very simple. So using depending on the colors of the buttons, you are going to control a different part of the observatory. The red buttons are for control the mount. The yellow buttons are for controlling of the dome, for open dome, closing the dome, and move the dome to the sun. And finally, the green buttons are to control everything related with cameras. The CCD apps, which allow us to see a live image of the sun in the 3 different filters, and IP camera app, which is for just a camera to control what is happening inside the dome. So one of the activities that they do here is the calculation of the sun's differential rotation. The images taken with our telescope are used to calculate the rotation period using the magnetic spots. They repeat this process a couple of times using spots in different latitudes so that they can clearly observe the differential rotation of the sun. The applet you are watching now is accessible using the link you see in the screen, in the below part of the screen. And we are now doing some changes about this. This app, I think, is quite clear that it looks old, and to be fair, it is not very attractive to the children visiting ISAC, as it looks like a homework or a school thing. So my co-interns, especially Carmen and Yepuf, is doing an amazing job in that sense, and I'm going to make you a little spoiler of the next app that we are using. Basically, the way it works is the same, but with a new look, which we hope that it's going to engage people more into the activity. Currently, it's just in Spanish, but we're planning to translate it to English in a short period of time. So also, as I said before, we take daily images of the sun with our observatory. The former CESAR's intern, who is called Antonio Ortega, designed this applet, which is accessible using the link you see in the screen. And this applet is used to compare the images taken with different filters. It is updated every day. This white bar that you see here, you can slide the bar so you can compare the different images. It is very, very, very useful. And also in our webpage, you can find the archives where the images are uploaded daily. So if you want to see how the sun was a year ago or 2 years ago, every image that we have taken with our telescope is available in that archive, in that website. So I would have loved to show you today's sun, but unfortunately it is very, very cloudy in Madrid today. So I just can show you this, which is the sun on last Friday. Well, so I think that for the sun is enough for today. So if you remember one of the first slides that I showed, we have 3 more observatories. First, the Bill 1 antenna, which is located in ISAC. This is the one that was used to send the telegram to Tea Garden B. It is located in ISAC, the same place as the Ilios Observatory. It has a diameter of 15 meters, equipped with a receiver in S1. This is practically a professional observatory, and we in the future are going to use it. It's going to be used by CESAR. Now, we are preparing this as we are building the Q system to operate the antenna. At ISAC, there is another antenna called Bill 2. It is very similar to Bill 1, but it has also an X-band receiver. And it is now being commissioned, and in the future, it will also be used by CESAR. This one is the NIX observatory. It is a night sky observatory. It is formed by 2 30-centimeter tubes equipped with dedicated CCDs. I am working directly with these 2, and we plan to have them ready in a relatively short period of time. They are also located in ISAC, next to the Ilios Observatory, and they are in preparation too. Finally, the Cebreros CESAR telescope, the CCT observatory, is a a 50 centimeters telescope equipped with a dedicated CCD2. This telescope will be in Cebreros, a village about 100 kilometers away from ISAC. Now, I say it will because now it isn't there. Now it is being refurbished and fine-tuned by La Ita Observatory, which is located in Toledo. They are doing a really, really good job. And we are in the last steps, and we'll be doing the commissioning of the telescope during the next week. So if everything goes as planned, we plan to have it ready before the end of the year. As I said before, just the Ilios Observatory is fully deployed now and taking daily images of the sun. But we plan that in a short period of time, the 3 observatories that I presented you before are going to be ready. And this is still not available, as I said before, but we hope that it will be in the next future. So I want to do like I want to explain what we are planning to do. How are we going to work with these telescopes? So we will propose some scientific cases in our websites. The school can select the case they want to perform and ask for observation time. The observation projects are going to be quite different, maybe about exoplanets, galaxy morphology, or to do photometry in stars. It's going to be different cases. So once the cases is accepted, we are going to schedule the observation, and our team is going to perform that observations. When the observations are performed, we are going to upload all of the feeds and all of the images to the CESAR archive, and the schools are going to be able to download that data so that they can work with it. We are going to offer different ways of receiving or of downloading the data. For example, for those low-level users, such as primary or secondary school, we will design a pipeline to reduce all the data. And for the higher level users, we will provide them the raw data with the calibration file so that they can do the whole process. After they download the data, they can do the scientific case in the classroom to finally do a presentation with the results at the end, maybe making a poster or other kind of thing. And yeah, they will work in class. We are going to try to do it, to use the VO tools, to use SalsaJ, DS9, or that kind of programs, easy to use programs, so that they can develop the scientific case in their classroom. And this will be the purpose for the 3 last observatories I just explained. We are going to try this with the CCT telescope, and if everything goes as planned, we want to extend this to all of our observatories. So this is the current status of the CESAR observatories. The Helios observatories for the sun is fully working, and we are working in the implementation of the rest of the observatories. When this is ready, we are going to give to the community a big network of observatories for educational purposes. Some of them are professional observatories, we could say. So that's all. Thank you all for your attention, and if you have any questions.
Thank you very much, Diego. That was a very complete presentation. Very glad to see so much new things happening. I don't see any questions so far. Only people clapping and saying very nice. I have a question for you. So you were talking about the number of students, the students that are receiving the data, etc. How are you convincing educators in your area to embark in the project? And the second question is, are you opening all of these and all the support to teachers wherever they are in the world?
Now, as I said before, it is not deployed, so we still don't have to convince anyone, I suppose. So yeah, I think that this is not public yet, so we haven't started with all of these things that I presented here. So it is probably a problem in the future. And I'm not sure if it's going to be open. I don't know if my supervisor is here, so he probably knows a bit more about this than me. But I'm not sure if it is going to be open to everyone.
Okay. And there is a question from Edward Gomez. What was the motivation for building a new set of telescopes when a lot of robotic telescopes already exist for education?
I think that CESAR had already these telescopes. They were they were just in the storage. So we decided to start building it. Also in Spain, I think that there is not such a thing. It is true that you can accept other robotic telescopes, but I think that it is better to do it local, so that we can speak with the teachers directly, or we can assist them directly. And they are also visiting ESAC, so I think it is a just to complete the experience. They visit ESAC, they do a space science experience here, and then also they can use our telescope with our help to develop these cases.
I think if I know a little bit of the story, the material was there, and the idea was to open it so people can visit on site. And Edward did also making an important recommendation that you work with the Peter project, which I'm sure you know is part of our dream team. So I'm sure you know them. Well, any more question or comment? We just have people clapping also here on Facebook, where there is a leg. If there are no more questions.